that? Because from what I understand, maintaining a continuous track on a target can be very difficult if incoming munition travels from one radar field of view to another, essentially. How is the networking? And I'm sure you're leveraging AI. What kinds of technologies are being used to sort of solidify that target track against one or several ballistic missiles?
Sure. So I think sensor fusion is something, a core capability that we have that we bring to the table to enable that tracking and the correlation across not only the different, maybe a radar field of view and handoff to a different radar, but you can appreciate that there's also going to be multiple modalities of sensors out there, say an IR type sensor along with the radar. So having the sensor fusion then and the ability to pair those two together. And then if you look at the scale of the problem, though, it's really quite impressive if you look at it, right? With the space-based sensors and trackers, we're effectively looking at the entire world at any one time and having to observe that and make decisions on the data that's being fed in. So there's definitely a problem of scale to be dealt with, I think, for this next generation command and control system that will need to get employed.
Excellent. You touched on AI and countermeasures. How is, in a manner quite similar perhaps to smaller drones, where you have an incoming threat and then an AI-enabled system can bounce sensor information off a database, make a discernment, essentially recommend an optimal countermeasure for that particular threat? I imagine Golden Dome is thinking in that way strategically in terms of concept of operation on a much larger scale in terms of the size of the threat.
Yeah, so I think AI can play a couple of key different roles in Golden Dome. I think, as we just talked about, identifying targets and tracking targets against, different fields of regards or through those field of regards. I don't necessarily think identifying possible targets is the hard part, but it's deciding which of those targets are actually real targets and not decoys that the enemy has employed to try to overwhelm your system or make you use effectors against a non-real threat to you. I think one of the other areas AI, as we talk about command and control, we talked about how big this network will have to be. And it's likely that anybody who's going to launch that type of attack at you is also going to attack your networks and maybe through electronic warfare and those type of things. So implementing AI at a layer where it's going to deal with healing the network and finding the most efficient way to get the data around despite those effects from the adversary, I think is really important.
Roger that, because if it were, for example, an urban area, you might not want a kinetic explosion or fragmentation. You might want to pick another countermeasure, whether it's EW, microwave, or if weather permits, maybe even a laser to incinerate or disable something, because those are scalable. What kinds of countermeasures will this network with? Are you thinking?
So I think everything is on the table at this point. Obviously, we've got a long history with your more traditional kinetic type effectors, and that's a core functionality of what our engagement management application does, is suggesting to the operator very quickly which effector the system believes, based on all the training that it's gone through, which effector should be used at any one time and when it should be used, just as you mentioned, to prevent the collateral damage. Now, if you look at, attacks in mass, especially against point targets, I think that's when you start to look at the other technologies, like you mentioned, which high power microwave, we've seen that be effective in situations, or on, as you mentioned, directed energy. But I think it all depends on the threat, the number of threats, and how fast that threat is coming at you, right? And I think these systems that we employ, and hopefully through the use of AI, are bringing those suggestions and courses of actions to the operators incredibly quickly.
I definitely want to make sure I don't forget to ask about AI reliability. First, I wanted to ask about layering, and I don't know if echelons is the right word, but how is the system architected, if that's the right word, to detect something from, say, terminal phase down to closer in, or perhaps a larger munition or something that becomes a smaller threat, almost counter drone? How can the larger layer and the closer in layer be synthesized?
So, as we spoke about before, I think making sure that all of those layers are networked together and across each other. Now, that presents a good amount of challenges, not only because of the different modalities that you're using, as we spoke about satellites, maybe with IR type cameras, maybe ground based radars, and putting that data together and fusing that data. Not only that, but another challenge that we'll have to overcome is the classification could be different for each one of those data sets. So bringing them all together and allowing that to happen relatively quickly is a very difficult network problem.
I really like what you said about AI and decoys, because one of the big industry efforts, and I'm sure Elbit America is very involved in this, is working on the phrase called zero trust. How can you make AI more reliable? How can you make sure it's not a false positive? How can you distinguish a decoy from an actual threat? What's your sense of how that's evolving? Because that seems so critical to the success of a system like this.
Yeah, so I think currently, right now, where we use AI, we're using AI to make a suggestion to the operator on what they should do. So that's a layer of protection. Man on the loop, if you will, is how we're currently using AI. I think to the latter part of your question, to address it, I really think we need to continue to train and train the system incessantly. And these situations aren't going to present themselves every day for us to learn from, right? We never want these situations to happen. So how do we go train our AI against these hopefully never come to truth type situations? I know the Missile Defense Agency does tests and those type of things over the Pacific, and we gain some data from that. But we also offer a capability that we call the Battle Lab. And this Battle Lab is similar to an ops center, if you will, but it's where we have trained the engagement management software over and over and over again, and not only made the software smarter, but also train the operators at the same time. So now you could use that Battle Lab ostensibly to go train your AI. At the same time, you can also train, your operators that are going to have to make the final decisions likely.
Well, now, from what I understand, AI can look at even more subjective kinds of phenomena and look at holistically at a host of different variables to make a discernment. What happens if an AI system comes across something that's not part of its database? You mentioned how quickly the system is learning. What happens in that scenario? How quickly can it assimilate, perform the analytics, and sort of make the requisite distinction?
So I think that's all based, it's going to come down to your rules of engagement and what you're going to allow the AI to do, right? We could build a system that in the end will make a suggestion to you and will tell you what to go do. But personally, I'd rather have an AI system that says, I do not recognize this situation. And then it's going to come down to, what we've always relied upon in the past is the human judgment to make that final end game decision.
Roger that. There was some discussion, and the DoD wrote an essay about out of the loop autonomy. Is there a place as AI becomes more reliable to make those discernments in milliseconds and save lives by having completely autonomous system without needing human intervention for purely defensive or non-lethal purposes? Obviously, the doctrinal requirement, human in the loop with lethal force. What about non-lethal force and potentially saving lives in a defensive fashion?
I think there's definitely room for that in especially a defensive fashion as the threats, hypersonics, and those are becoming increasingly fast. And at least with a ballistic missile, you knew where a ballistic missile was going to go based on the trajectory. Now with maneuvering hypersonic threats, you might not have the time, as you suggested, to have a human make that decision. So I think in a defensive situation, we could definitely see us using autonomous systems and them making the decisions.
Excellent. Excellent. Well, what you just heard is reason why we hope you'll all stay with us on this series, because we're going to bring you the most cutting edge expertise like you just heard right here. We want to thank Elbit America's Chief Technology Officer, Mr. Matthew Steenman. Unbelievable expertise. Thank you so much for what you're doing for the safety of the country, and then also for helping us understand the importance of the expertise and the technology.
Great. Well, thank you very much. I appreciate the time, and hopefully we can chat again.
Absolutely, sir.